Hello, everyone, and welcome to this session on neuroscience-centered selection criteria for data repositories and scientific gateways. I'm Bjaalie, professor at the University of Oslo and infrastructure director of the Human Brain Project, building the eBrains research infrastructure. Over several years, I've had the pleasure of working with and also within the INCF. The sharing of research data and software tools for making use of the data is a key aspect of neuroinformatics. But neuroscience and neuroinformatics are not alone. Most scientific disciplines are dealing with data sharing one way or the other. And there is a new wave of activities related to making data fair, findable, accessible, interoperable, and reusable. The term fair was, of course, introduced in 2016 in an article in Nature Scientific Data, first author Mark Wilkinson. Since then, the FAIR data principles has acted as an international guideline for high quality data stewardship. So while the term FAIR has been around for about 5 years, the activities in this domain has been around for quite a while, as you will hear and see from several of the talks in this session. One of the talks today are perhaps fairly neuroscience-centered, but most of the talks are not, but they reflect what's going on in this domain in general and what we can learn about that when we build data repositories and when we search for the ones we want to use. So there is a lot to learn from these different initiatives and activities in many areas, and this is your chance to be updated, also to ask questions in the chat. And we'll go through these questions after the presentation, or primarily in the discussion at the end. So please, all of you who are in the Zoom room, or those of you who are watching the streaming, use the chat for questions and comments. We cannot guarantee that we will converge on a common set of recommendations for the neuroscience community today, but we will, of course, make progress for sure. So over 5 speakers will introduce themselves, and we might take 1 or 2 questions in between, but mostly have Q&A at the end of the session. So then we will begin with Susanna-Assunta Sansone from fairsharing.org. So Susanna, please, welcome.
Thank you very much, Jan, for the kind introduction, and thank you for inviting me. Shall I introduce myself before I start the slide?
Please do.
Okay, so my name is Susanna-Assunta Sansone. I'm an associate professor in information engineering at University of Oxford, where I run a group on data readiness. Now, for sharing, it's one of the activities that we run in the group as a community service. But the hat I'm wearing actually here today, when I introduce you the concept of a repository feature, what's happening out there, it's really more as a chair of the RDA 411 registry, for sharing registry, which is a working group in the Research Data Alliance, connected to the 411 group as well. And the focus is to connect data policy, standard, and databases. So I will give you a presentation of which cover the activity of 2 sessions that we ran last week at the RDA, which are very relevant to the topic we are discussing today. And here it's the name of my fellow chair that co-lead the for sharing registry. So before I explain what the sessions are about and we go and dig into the outcome of those sessions, I want to give a very brief overview of what the for sharing group is and does and what has delivered so far. So it has delivered 2 outputs, a registry and a set of recommendations. The registry, which is available at forsharing.org, practically describe standard, data standard, metadata standards, covering format, terminology, guidelines, identifiers that the community has developed across all the disciplines. And repository of data and other digital objects, as well as policy being developed by funders, by society, by alliances, by publishers, etc. And what actually the register does, register them, describe them, and link them together. And I'll explain you why the link is a very important feature of the registry. Associated to that are a set of recommendations that really help the user of these resources, the consumer of these resources, to find the resource that's relevant to their area, to their case, to their application, and use them. But also, we are really also working with the producer of these resources, the people that develop the standard, the people that develop and maintain the databases, the people that create the policy, so that they can actually make this resource discoverable outside their direct domain, and also make them more citable, more visible, more adopted. So this is an example, as there are many resources out there. And for example, we have used the connectivity, this knowledge graph of fair sharing, to, for example, represent the number of standard and repository which have been recommended by the RDA COVID working group in making sure that data get shared according to proper standard and deposited in the appropriate databases. So in association to the paper, you have this visualization that actually happening for sharing. The question is, obviously, you want to find what's relevant to you. So you are in the neuroscience area. If you type neuroscience, you will find out that in sharing, there are more than 140 resources between standard and repository in the neuroscience area. And many of those have actually been contributed by you. We've also worked, for example, with the INCF to create a collection of the standard that you recommend. And although you only have 5 standards that you recommend, this has been your input in creating this collection in fair sharing. What the power of fair sharing does, that actually adds the value by showing which repository it's using the standard that you have recommended to your community. So in this case, I want to highlight, for example, that the brain imaging data standard, which is one of the ones that you recommend, it's been implemented by several databases. And so in fair sharing, although you have not entered all the databases, they've been connected to your standard and can be displayed. And so you can also see that BIDS also use another, is implemented by another databases, which also implement 2 more standards from the INCF community. So this connectivity, it's an example of how users are using the fair sharing registry. And here I'm just giving you 3 broad examples. So people create collections like you have done. Other people have done, for example, in astronomy domain, they create a collection of standard and repository they have developed or that they want to recommend to their community. And so fair sharing helps as a landing page to visualize these resources and their connection. Policymakers have registered the policy in fair sharing so that they can try to understand what is that they need to recommend according to the type of policy they are developing. So in this case, fair sharing serves as an educational resource. They show to people what's out there and what they should, how they should evolve their policy, because sometimes this policy get developed, but they never evolve, they never get updated. Another group of people is accessing the content in fair sharing to use it and consume it, for example, when filling data management plan by selecting the repository and the standard relevant to them, or when they build this knowledge graph like DataSci Commons is doing or OpenAir it's doing, for example. And so the content is surfaced, and we are working with this group to make sure that it's surfaced in other knowledge graph. But so this is really an overview of what fair sharing as a registry is. But now let's go back to the session to understand why we have done certain session in the context of what I've just explained. So practically, the community that has used fair sharing has realized that they want to have more descriptor of the standard, more descriptor of the policy, more descriptor of the repository. So we need to work with them to improve the descriptor of these resources. And that's why, as a working group, we are following 2 tracks. We are working with policy maker like funders and publisher who are developing data policy and try to align them so we can better describe policy. But we also try to understand all the different activities which are out there in terms of feature criteria and characteristic for repository, and see if we can use them as a descriptor in fair sharing. So I will give you very briefly an update of what's happened in the policy session, and I will go in the repository session because the 2 are related, and hopefully I'll be able to explain very briefly in a few slides. So the policy alignment session, which is driven by the funder interest group and the policy interest group within the RDA, with the collaboration of the fair sharing working group, has the objective of understanding funders and publisher policy. Can they align? Can they share the common template? templates so they can similarly described. And so the rationale is because both funder and policy want to influence and motivate the sharing of data by researcher, and align the policy might actually be an effective way of trying to do that. And the focus of this work, it's really more on data policy that enhance the availability of the data and the deposition of the data in repository. So the plan, as part of this three working group, the policy interest group, the funder interest group, and fair sharing working group, is to follow a plan that has three phases. The first phase is to do some analysis, which has already been done by the colleague in the funder working group, interest group, and understanding the landscape of the policy which are out there. Now, the second phase is to try to see how we do this alignment. Can we share a common template? And the policy interest group in the RDA has created already a template with 14 features to describe a policy. And this one, it will be probably tested as a common template. And this will be done iteratively with the community input and feedback. The phase 3 will be about, okay, now how do we apply these recommendations and this template? How do we test it? Does it work? Does it help us to promote data availability? Does it help us to promote data sharing repository? And the fair sharing working group, among any others, will be an implementer. We will take the template and we will use it to enhance the fair sharing registry so that when we describe the policy, they're more comparable. But let me explain you why we need this comparison. In fair sharing, we have this policy dashboard where whoever creates a policy, in this case, a journal, scientific data, has the policy, register the policy, and describe what standard and repository they recommend. We need to be able to actually see that, to really see how many standards, how many repositories, and if these are connected. And that's why we need this graph. And this is an example of a graph by the Wellcome Open Research, which is a funder-associated journal that recommends standard and repository. But we need to be able to understand, do they recommend the same thing? If not, why? It's because maybe the journal editor or funder isn't aware of those repositories out there or certain standard out there. So we need to be able to compare. And in fair sharing, we have some beta feature, which we will enhance in terms of comparison. In order to compare in policy and their strength or weakness in terms of how much they promote data sharing repository and data availability statement, we also use the top guidelines. And this is an example of a journal from a society, a policy from a funders, and a policy from a publisher. And you can see they have different type of top level score according to the data transparency. And this is a very good way of comparing it, but it's not an easy way because nevertheless, those policies are described differently. And in order to give the score of the top, you need to interpret the policy and what the policy says and enforce or does not enforce. So we can all do more, and certainly fair sharing will help to do more in the sense that if we are able to describe the policy from the funders, from the society, from the publisher in a comparable way, we will certainly help the researcher to understand better those policies, to really follow the data availability plan, to meet the requirements, and to make data available in the repository, because this is the ultimate goal. Right. Let's go back to the second session that we ran at the RDA, and this was run solely by the fair sharing working group. The scope of this other session was really to understand the repository feature, how we can enhance the description of repository and fair sharing. And there is a number of initiatives out there which have defined feature, and I'm going to use this word to refer to many things, to refer to criteria for certified repository, to refer to functionality that certain repository offer or certain user want to see, but also to refer to good practices that have been developed as guidelines to assist the repository to improve their operation. And there are many groups out there, and we invite the key. Can we understand if there is a commonality? Can we bring them together? Can we find a common set of features that fair sharing and any other registry can implement to better describe repository? That's the scope. So we had several presentations, and I have just a couple of slides on each one. And I've taken the slide from the presenter, and I haven't changed the content. I only tried to summarize as much as I could using their own text, their own description. So the first presenter was from the publisher group. This is a group that has develop a set of features for describing repository the publisher believe are important when they recommend repositories. So they can try to recommend in a very transparent manner. This was presented by Matt Cannon from Taylor and Francis and Chris Graff from Wiley, and those are the participant publisher in this activity. The scope of the publisher was to try to really, like I say, guide the researcher, because the researcher asked them for guidance. And the way they were recommending repository wasn't transparent. And they got together pre-competitively, trying to see if they could give more transparent guidelines and make these guidelines, these criteria or feature more transparent to other communities, so that people will understand why certain repositories were recommending over another. Now, what also they have done is to create a mapping table, mapping the feature that they have identified along with the feature identified by the COAR Trust Seal, Trust, COAR, NHS, and the Elixir, which also were other presented in the session. And this really table shows that actually, with the exception of two features, which were very publisher specific, like access for pre-publication review and data deposition condition, everything else was also already been identified as an important feature by the other initiative. The second group that presented was the Elixir, which is the European, a pan-European infrastructure for sustainability bioinformatics in Europe. And Elixir has defined a set of indicators that support the selection of core data resources, because there are many resources within Elixir and outside Elixir, and they need to be identified and prioritized in terms of quality, in terms of legal and funding infrastructure, in terms of community uptake, in terms of impact, in terms of scientific focus. So they've created their own features, their own indicator, which are really now core part of the Elixir process moving forward. But those indicators have, in this way, by using the indicator, a set of core data resources have been selected within Elixir, but they've also been adopted outside Elixir, in this case by the Global Biodata Coalition. Now, the Elixir feature, the Elixir indicator, partly mapped to the FAIR principle, partly also mapped to COAR Trust Seal, but they are very much focused on impact, which is a slightly different angle than, for example, other initiatives have. The other presentation was from the COAR Trust Seal initiative and was presented by Mustafa Mokrain, a part of the board. And the focus of the COAR Trust Seal, it's really trustworthiness, which is at the center of preserving data and in community repository, which are designed by the community as well. And the COAR Trust Seal, again here, just a snapshot of the presentation, which is a large uptake. It's a formal process, and there is a peer review, there is a self-assessment, there is a review board, there is a certification, there are some charges, and the certification is valid for 10 years, and there is a big uptake as well. But the focus is trustworthiness, and they have a set of criteria, some of which indeed map the type of feature that other initiatives have also indicated as important for the repository. The other initiative that presented was the Science Europe, represented by Mary Tinemar. I'm sorry if I don't spell people's name correctly, I apologize for that. And she's a senior policy officer at Science Europe. The Science Europe brings together public research funding organization with research performing organization, mostly based in Europe, obviously. And they have released also a guideline, a research data management guideline. And actually the scope of this guideline is really to support researcher and aligning the funders with the research institution as well, and is trying to be as inclusive as possible, taking in account other existing initiatives, but leaving the flexibility to the researcher, the organization, the funder, on how to choose the repository. So these are very high-level guidance in the case of the Science Europe. The other initiative that was represented at our session is the trust principle for digital repository, and the presentation was done by Wei Lin. as part of the NIH, and in a way it's one of the author of the trust principle, also published in Scientific Data. So trust stands for transparency, responsibility, user focus, sustainability, and technology. Now, how is this different or similar to the other efforts? That we had a very nice picture which really illustrates the fact that trust, it's about aspirational. It's almost like the first principle because they are aspirational, but trust are also aspirational principle. And then there are frameworks, and then there are implementation, for example, a core trust seal and all the other are implementation of those aspirations. And the focus again, it's trustworthiness here. And again, also trust, it doesn't tend to replace any other standard or any other criteria or any other best practice, but it's about advocacy as well. And there's a big uptake as well of the trust principle. On the left-hand side, it's the list that we provide as one of the core uptaker of the principle. The other initiative that was presented was by Jerry Sheehan, and Jerry is the deputy director of the National Library of Medicine and NIH, and Jerry presented the NIH recommending approach for selecting data repository. So these are characteristics for repository, discipline repository, and very data specific repository that the NIH would like to see, and they have collected also through a request for information that they've run for a long time. I took this slide out of his presentation that shows the motivation for the NIH to develop those characteristics. The motivation is it's creating consensus of these characteristics so that they could provide guidance to the community on how to select the repository, how to identify and even develop even new repository, identify existing repository and develop a new one. So the idea, the benefit, it's generally the same. It's improved consistency for researcher when they select something, reduce the complexity for the researcher when they need to comply with the policy, so everything becomes simple across the NIH. And obviously they want to also assist the researcher to do better data management and develop better data management plan, or clearer or more detailed data management plan. And obviously the generic ambition is to share fair data. And the characteristic, again, very much there is a lot of overlap with feature in other initiatives. And then obviously Kathleen Shearer presented as executive to COAR. She presented the COAR repository practice, but like I say, because Kathleen is going to present later, I'm not going to summarize what she said because she will go in much more detail than I can. So as a conclusion, and this is really, it's actually my last slide, what we concluded, we had the presentation in detail of all the initiative. We had a panel discussion and say, what do we do? And the discussion was really very useful because there is a different angle from which this initiative come from, and the reason why they have developed this indicator or feature or characteristic or they're differently called, but there is a generic willingness to come together and identify some core characteristics which maybe are common to all the stakeholders that could bring all these parties together, and they ultimately can be used by registry as fair sharing to better describe the repository, to better promote selection, identification, discovery of these resources, of the data resources. There was also one of the points that came up was that clearly we need to better define what we are talking about, and most of the people agree that feature, it's something that should be used connected to the functionality. So feature is more a functionality that something need to adopt, but the best practice, there are more guidance for improvement. And some of the initiative who presented, some of them really define feature, others only define best practice. So we really need a better classification of this initiative so that can be better understood by others and by the researcher ultimately. There was also another important point everybody agree on, which is we need to be very sensitive on how we apply those feature of those best practices, because this is an evolving landscape, and we need to promote the proliferation in a way of repositories. Some people say we have enough, some people say we don't have everything that we need. So overall things will evolve over time, and we need to be sensitive that this ecosystem is in growth, is evolving. And so we can't have things which are fixed at work now and perhaps don't work in 5 years time. And so we need to realize that. And we also we should reflect what the researcher needs, and also the need of the researcher should change. And therefore, anything that we decide need to be able to evolve over time to meet the researcher requirements. In terms of next step, or what's actually happening right now. So first of all, we're writing up a summary of the session, and we will definitely involve all the parties to make sure that we capture all the nuances of the different initiatives. If you are interested to understand what's going on, feel free to register to Fair Sharing Working Group. We will communicate to on that mailing list, on the RDA Fair Sharing Working Group mailing list, what's going on. There was also an agreement to start working together in a new group that will be defined as a charter. And at the moment, we are working with the speakers of the group to see if they want to be involved, and we will open up the charter to more people so that we can have more members, and a core group will start writing what the mission will be based on the session and on the outcome, and then everybody can join. And obviously this will have to go through the usual RDA approval process, which some of you I've already done, can take a few months, and then there will be a 18-month lifespan, and then there will be the output of the working group. So this is my final slide when I say we can all do more. Certainly for sharing as a working group and for sharing as a registry that my group run will do its part, and everybody needs to do their own part. We are all representative of key parts of the scholarly community, and we must not forget that we are all here to support the researcher. They ultimately are the center of this. So it's really imperative that we work collaborative, we understand each other, and we really show willingness to show and work with each other. Thank you.
Thank you very much for this excellent overview. So in neuroscience, we do know we are at an early stage. But if you look at the whole landscape, would you say what you described is at an early stage still? There's a long way to go before we're seeing where this is heading, or are you seeing some level of maturity here in terms of?
I think, well, if you are specific, ask me, Jan, in terms of repository description or in generally on promotion of repository?
Maybe the first, the repository descriptions, perhaps. Yes.
Well, I think we're getting there. I mean, the fact that all these initiatives have tackled the problem from their own viewpoint individually, I think this was a very important first step, okay? We all have to do this individually. And I think the idea that people were keen and very happy to present in this session means that there is a willingness to work with together. And I think this is the beginning of a journey that can be long. Depends, like I said, if the work is going to proceed, progress through this RDA working group, it will be, you know, maybe a year or something until we come up with something. But, you know, it's the start. If you don't start the journey, you will never arrive. So, yeah, I'm optimistic.
That's very good. So everyone, just make a note of the things you want to discuss, and we'll return to this. There's a lot of links here also to journals that I think we should touch upon later today. Thank you. Let's move on to the next talk in our list. That is by Daniel Katz, University of Illinois, Force 11 Software Citation Journey. So Daniel, please introduce yourself and go along, please.
All right, thank you. So I'm Dan Katz. I'm the chief scientist at NCSA and an associate research professor in a few areas at the University of Illinois. I want to just start off by thanking the co-chairs of the two different groups that I'm going to talk about, and I'll go through this in more detail as we go. First, just to mention, Force 11 as an organization has had two different software citation working groups. There was a software citation working group in 2015 and 2016 that published a set of principles, and then a software citation implementation working group starting in 2017 that's currently going. What we're trying to do in these two different groups is to provide credit for software developers and maintainers within the scholarly academic system, with the idea that this will create and incentivize better and more sustainable software overall. And we're also trying to support reproducibility. But we recognize that software citation is not sufficient for reproducibility. It's sufficient for credit. So just kind of jumping back to the beginning then, in 2015, we started this Force 11 group with Orphan Smith and I as co-chairs. There was another activity going on around the same time called WISPE, Working for Sustainable Software and Science, Practice and Experience. And its third meeting happened also in 2015, and there was a credit and citation working group that I co-chaired with Kyle Niemeyer, and we realized as we were going there that we were really trying to do the same thing. And so we brought the two groups together in the Force 11 group. So the group overall had about 55 members, researchers, developers, publishers, repositories, librarians. We did all of our work on GitHub, and you can still see any of all that if you're interested. And we started by reviewing community practices and developing a set of use cases around software citation. We then drafted a software citation principles document, and we started with the data citation principles that had come out a little bit earlier. We updated those based on the software use cases and software related work, and then working group discussions and community feedback and a draft and review of a draft and a workshop. And we also along the way wrote a couple of other papers, one being a preprint on why software and data are different in the context of citation and why we can't just use data citation principles. And then the second as a set of challenges that we thought at that time were the important things about looking at software for credit identification, discovery, and reuse. And so you can see we're kind of thinking a little bit fair-like here. We then published at the end of this working group a paper on software citation principles, and it's available. And the principles itself, there are 6 that are somewhat the same as the data citation principles, but also somewhat different. And so just briefly, importance is that the software should be considered a legitimate and citable product. Unique identification is that the software citation should have a method of identification that's machine accessible. Persistence is that the identifiers and the metadata should persist. Specificity is that you should be able to look at the specific version of the software that was used. Credit and attribution is the purpose of this work. Again, the citation is to give credit and provide attribution. And accessibility means that the citation should facilitate access to the software itself and its metadata. So this was basically the work that we did in this working group. We then realized that the principles by themselves weren't enough, and we started a different working group, the Software Citation Implementation Working Group, to write out the small amount of detail that was needed to implement the principles, to coordinate research and other work that's going on in a bunch of areas, and to work with communities to actually implement the principles. And those communities are publishers, conferences, repositories, indexers, funders, things like that. I'm working here on in this group, which is still going, with Neil Chu Hong and Martin Fenner. We, in the next year, basically formed a good group, had a lot of good people with diverse interests and expertise, and we did a bunch of good work initially, and helped coordinate a bunch of ongoing activities. So this included things like metadata standards and translation, where we worked with DataCite and their new schema that they issued to make sure that it facilitated software discovery, sharing, and citation. And specifically, it included 2 new relation types and new documentation that were intended to support software citation. Caltech Data, Tom Morrell, who's going to talk next, did some work to support this metadata file. And we've also been doing some communication and building some new tools for using both CodeMeta and another way of storing metadata, citation.cff. These are both metadata files that are in a repository along with source code, so they stick along with the source code as things move. There's also was work on open source archiving and identification in a group called Software Heritage, which is basically the Internet Archive, or archive.org, for open source software. And we had some good work in initial acceptance in communities, including astronomy and earth science and math and high energy physics. But later that year, we realized that that small amount of detail that we thought was going to be needed wasn't really very small, and that scattered progress wasn't enough, and that we had a bunch of underlying challenges that weren't addressed. And so we wrote a document, a preprint that's on archive, that was intended to identify these challenges. And of course, it's called Software Citation Implementation Challenges. The technical challenges that we talked about include the complexity of software types, the fact that software can be open source or closed source, it can be published or unpublished, it can be versioned or unversioned, it can be developed by the person that wants to cite it, or it can be developed by somebody else. It can be packaged as a service or in a container or as an executable in addition to the code itself. And so one of the challenges that comes out of this then is how do you uniquely identify software of each type? Or ideally, you'd like to identify software of each type as uniformly as possible. And so we were involved in the Force 11 RDA software source code identification working group to look at this. How do we define and store the citation metadata for each type? How do you access that metadata and convert it as needed? How do you count citations across versions? And so one of the things that we realized here is that metadata really is fundamental in this challenge. There's also a set of social challenges that we need groups that work on implementation in context. And this includes disciplinary communities like the one here, and publishers and repositories and indexers and funders and institutions. And these groups need to come together and then run pilots to establish norms that actually will work for those communities and for those groups. So the things that we've done since then is to try to respond to these challenges. We started a bunch of task forces in areas where it seemed like focus implementation work was needed, in particular on guidance, on metadata, on repositories, and Tom Morrell is going to give a talk about this next, and then on journals and publishers. And we also are talking about other areas that are more complex or larger. And we have an IMLS grant for a workshop and plan development that we thought was going to happen last spring, and is currently on hold because of COVID-19, excuse me. So the different task forces I'm going to go through really quickly. The guidance task force that Neil Chu-Hong has led basically started off with the idea that checklists are an effective way of ensuring consistency and completeness. And so it's developed two checklists, one for paper authors and one for software developers. And so each of these basically says, if you're writing a paper, how do you cite software? If you're developing software, how do you make your software citable? The group also started a checklist for paper reviewers, but it's on hold pending some of the other groups. The Code Meta task force is basically trying to figure out what metadata are needed to describe software. And so the Code Meta project itself built a crosswalk of a bunch of different metadata standards for software. And then it developed a separate standard that describes software based on these crosswalks using JSON-LD and aligning us with schema.org. And so the Force 11 group then reached consensus to use Code Meta as the standard to describe software. And it is now working on updating the Code Meta standard and describing everything in Code Meta using schema.org, with the idea that Code Meta could become a community group and schema.org would become the standard. And then we will, this group is also then working to increase adoption through documentation and workshops and tooling. The software registries task force, I'm going to skip. I just put this in the slides for the record, but Tom will talk about this next. And I'll talk about the journals task force as the fourth, which I've been leading with Shelley Stahl. And so the idea here is that journals and conferences need guidelines on what authors should submit regarding the software they use. And so we, in this task force with about 20 publishers, we've written an F1000 research paper. And then we've publicized this via Scholarly Kitchen guest post and a bunch of different talks. And this basically provides guidance for journals on what they should tell their authors about how citations should look. The next piece of this is once the journals actually get citations, papers with citations from the publishers, they need to actually then process those papers. So the papers need to get converted into a machine readable format, XML or JATS or something like that. The citations need to get transmitted to Crossref. They need to be indexed. So there has to be some way of knowing that they're software. And the task force is basically working to understand and fix a bunch of potential and a lot of actual problems that happen in all of these steps. In the back end, there's a bunch of different issues where the citations don't actually get into the indexing system in the way that we would like right now. So overall, I think we've raised the profile of software citation with a bunch of different stakeholder groups. Again, we've done, I think, a lot of good work, and this is starting to have a number of effects. Tracking these effects is one of the research challenges that we're thinking about looking at. We'd like to understand if we can determine if software citation is increasing over time, and if so, if it's due to our work, or it's just due to the fact that software is more and more increasingly used in published work. There are a bunch of other challenges that really remain. One of them is that we have a bunch of different identifier types. There's at least 5 or 6 different identifier types for software. Some are discipline specific, some are general, some are things like DOIs, some are things like software heritage identifiers. And so how to get all of these to work together is an open challenge. And where and how metadata should be stored, particularly for non-open source software, is another challenge. And then it's worth mentioning again, as I said at the beginning, that citation is a fairly specific activity looking at increasing credit within the context of fair and open and reproducible goals. It really is just part of what we need. So I'll just kind of end with this slide that kind of summarizes where we are. And again, these slides are on Zenodo. They're actually slightly out of date there, but I'll update that in the next half hour. And yeah, and so that's where we are. I think we've done a bunch of work. We have a bunch of work left to do. But I think the idea of software citation is starting to catch on.
Thank you very much. That I think was very informative for a number of developers of various resources who might want to check with what you have told us about. In case there should be any comments or questions from anyone in the Zoom room, you're free to unmute and give a comment. And on my side, I'm just wondering a little bit, there are all these open alternatives, so to speak, and do you see an opportunity for kind of closing the door to some rooms and kind of coming together for something, so we don't just spend too much time on discussing forever, because it's important to have progress on this. It affects many people.
Yeah, I think the answer is kind of yes and no, as is probably a typical answer, that that we have different communities that have gone off in different directions, and I don't think it's realistic to get those communities to say that what they've done is going to be superseded by something else. But I think we can do a lot of federation. So I think there's a lot of things we can do to let communities do what they're doing, but to do some translation so that everything is more interoperable and more commonly storable in some sense and commonly searchable in the end.
Yeah, that's good. And maybe there is a chance to influence some of what's going on and see if one can bring it together a little bit as well.
I mean, unfortunately, we're at I guess this isn't really unusual here, but it's standards usually develop after there have been initial cases, and it's hard to get people to give up on what they've been doing. So if we'd been really clever and we'd come up with a standard before there was a need for a standard, we'd be in much better shape, but that's almost impossible to do.
That's not the way things work in general, for sure. Thanks a lot. Let's move on to the next topic, and that is by Tom Morrell at the Caltech Library, developing the best practices for research software registries and repositories. So please, Tom.
Thank you so much. Yeah, so I'm at Caltech Library. I run the Caltech Data Institutional Repository for both data and software. And one of the things that I'm particularly interested in is how we manage software metadata and how we work between different systems. So that's one of the reasons that I got involved in a lot of the Force 11 software citation implementation work that Dan just talked about. So today I'm going to be specifically talking about our work around software registries and repositories, and we've developed a set of best practices. So this work was really spearheaded by Alice Allen, who's at the University of Maryland and runs the Astrophysics Source Code Library. And this work also had some very generous support from the Sloan Foundation. And my slides are also on Zenodo, so they're going to be available. They're available now, and they'll be available after the talk. So today I'm going to talk to you about the development of the best practices, what our process looked like. Then I'll give a short summary of each practice, and then what our next steps are. And before I begin, I really want to highlight this is a very much a community effort. So there are, I'm a representative of a large group that came together to figure out what these best practices should be. And we have over 25 different software registries and repositories that are often for specific domains, or like me, for institutional repositories. And we had a whole process to figure, okay, what should best practices look like for these types of resources where we're hosting or managing or identifying research software. And we really used a consensus building process. So we had monthly early and late calls in order to capture as much of the global time zones as possible. And having 2 calls per session was actually very helpful, because oftentimes the early call would start kind of discussing and pinning down some of the best practices, and then that they could leave kind of open issues for the late call to discuss. So that process worked really well. We also had an in-person workshop, which was funded by the Sloan Foundation, that helped to kind of condense down what the best practices were going to be. So the process really was, we started out with a very large list of potential best practices. What are, as kind of repository managers and registry managers, what are the issues that we came across? So we basically had a very long Google Doc with, these are all of the potential situations that we've run to. These are all the things that we wish we had better policies and procedures for. Once we had everything possible, we kind of grouped those together. And then we kind of discussed and asked for consensus as to whether a specific practice was really a best practice, whether it was appropriate to fit into the official list. And then we wrote those up, and they're available as a preprint up on archive. So the preprint has much longer descriptions of every best practice. It has links out to resources. So if you're really interested in that, please take a look at the printed version. So this is just kind of a summary to kickstart the discussion. Okay, so the first best practice is to provide a public scope statement. So for your resource, for your registry, you really should describe what your scope is. So what type of software are you collecting? What type of software is in your registry, either hosted or indexed? What things are accepted? What things are not accepted? Why do you make certain decisions? And are there exceptions to that policy? This is a really clear statement of what's that scope for your resource. The next one is to provide guidance for users. So this, we're thinking about just people that are accessing your resource. What do they need to know? So how do they perform common tasks? What's the search behavior? Are there, what are the kind of frequently asked questions that you get on support tickets? As well as, what is your contact information? So if somebody has an issue, has a request, how do they reach out and contact the maintainer of that resource? Also, one of the best practices is to provide guidance to software contributors. So the folks that are writing the software that might want it to appear in the registry or the repository, what do they do? Who can submit entries? What does the process look like? What is the required and optional metadata? So what fields, what information do you need in order to process something to get it into the registry? What does the review process look like? Is there review at the registry or repository level? Is there some sort of peer review? How is that done? As well, what is the curation process? So what types of things are you looking for in the metadata? What type of things are you reviewing the software itself? What type of things are you looking for there? So to really lay out what your policies are for getting software into this resource. And also, what's the procedures for updates? How do updates work? Can they come from the community? Can they come from just the authors of the software? So just lay out how updates and changes happens. And also, how do updates reflect in the records? Is there kind of a history of records, that type of thing? So really kind of to provide clear guidance, as the community generates software, how do they interact with your registry or repository? Another best practice is to have an authorship policy. So how do we assign authorship? If we're talking, like Dan was saying about software citation, one of the really key things about software citation is identifying who the authors are, who should get credit. for writing a piece of scientific software. So you need a policy in order to describe that. When can authorship be changed? And this kind of ties a little bit back into some of the guidance for software. How do we do versioning? How does the registry track changes to the software? And how does authorship change over time? You should also have an authorship dispute process. So if we're saying that software citation is important for giving credit, then people are going to care about whether they're listed on a piece of software or not. So what's your policy in case you get a dispute? When somebody says, oh, I should be added to this entry as an author, or I shouldn't be added to this entry as an author. So a registry and repository really needs to have a process for handling those types of disputes, and a defined set of information about what the resource will do in the case of a process. How do you handle figuring out who should actually get credit and who should be listed as an authorship, listed as an author on a piece of scientific code? Another best practice was around sharing your metadata schema. And we had lots of discussions about metadata. And one of the things that was really clear along the group is we weren't going to, come up with a fixed set of metadata. We were never going to have, one metadata schema that was going to be consistent across all these repositories. So what we landed up on as a best practice is to actually just share out what your schema is. And this could be, a reference to an existing standard schema with a version number. But a lot of these registries and repositories have their own internal schema, their own internal way of managing the metadata. So if you can just provide a description or a data dictionary, that is also acceptable. We also said that we should provide documentation for the metadata. So even if you have a standard schema, how fields specifically get entered, how fields specifically get used, can really vary from resource to resource. So we want each registry and repositories to not only just provide the fields they're using to describe the records, but also how those fields get used. As also which fields are required, and specifically the format of the content in each field. So instead of in the best practices saying that there's one magical standard that's going to solve everybody's specific use cases, we left it as general. And we said, the best practice here is to share your metadata and to say, this is how we're doing metadata. The reason that sharing is important is then it allows others to crosswalk those resources and to be able to do tooling that doesn't force everybody to use the same metadata format, but to really just be able to translate between different resources. Another best practice is conditions of use. So these are some legal stuff. So, legal disclaimers about what is the responsibility and liability of a resource. So you as a software registry, what is your responsibility for the codes that you're hosting? What's your liability? Do you take any liability for things that might happen if people use the code? Also, license and copyright information for both the entries and the resource as a whole. So as a resource that is hosting software, there are licensing conditions associated with each of the software that researchers are contributing. And there's also copyright and license available for, say, the entire corpus of metadata that is associated with your resource. So what are your licensing policies around those items? Are there any conditions of use for your metadata? Do you allow, let's say, researchers to reuse your metadata, but not commercial usage? Those types of terms and conditions for how people use your metadata should really be spelled out. Piggybacking on some of the software citation work Dan was talking about, best practice really is to include a preferred citation for each code that is in the registry, as well as a preferred format for citing the entire resource itself. So we want not only there to be citations of the codes that are hosted in each registry or repository, but we also want individual credit for and citations for the resource in the registry itself. So we want everyone to get credit for their work. Another best practice is to state a privacy policy, and this is a little bit based on some of the GDPR requirements. But your privacy policy should say what user information is being collected. So for users, for your registry or repository, what are you gathering? How long is that data being retained? If you're collecting personal data about users of your resource, how is that being used? If you're doing tracking, say using Google Analytics or another service that looks at visitors to web resources, what is that tracking doing? How are things stored, and whether cookies are being used? So that is another best practice that's really important, both from a legal perspective, but also just we want to be respectful of the privacy of our researchers that are using these resources. Another best practice was to provide a retention policy. So, one of the things that we see oftentimes in kind of some of these research-funded projects or grant-funded projects is they'll be created, the resource will be available, and then it won't get refunded in the next grant cycle, and then it vanishes. So we really want resources to provide what their retention policy is. So what is the length of time that metadata or files are expected to be retained? Are they saved for a certain period of time, or old versions saved for a certain period of time? What's the policy around that? And also to list explicitly under what conditions are metadata or files removed. There's always some cases where things need to get taken down. So those should be listed out. Who has the responsibility and ability to remove information? Can the researchers themselves say that they want a code to be removed? Does it have to come from the community, or does it come from the owner or the manager of the resource? And what are those procedures? If there's a request come in, how did that request enter into the system? How does the manager look at it? And what are the decisions that are made about removing content? And the final best practice is around end-of-life policy. So once a registry is unavailable again, what's the plan? So when might the resource end service? So if a resource is grant funded, it's really a good practice to say on the resource, this is grant funded, we have funding for X amount of time. And after that point, what the plan is. What are the consequences that are going to result from the closure? So let's say if you're running something like a scientific gateway, maybe you'll say, well, we're going to make the metadata available, the software that we've gathered, that will be available as open source, but you'll no longer be able to run it in a live fashion. So to figure out what's going to happen at the end of life for a resource. What's going to happen specifically to the metadata? Is that metadata going to be available in some archived fashion? What happens to the software artifacts if you're collecting software? And then specifically, if you're a resource that is claiming that you're responsible for long-term preservation, like many registries and repositories are, where is that content going to be migrated to? What is your plan? How are you going to fund moving your content to another resource? So to really think about the entire life cycle of these types of registries and repositories, and to have a plan to ensure that the work that you're doing now in collecting, curating, storing, maintaining these things is available for the long term. So those are the 9 best practices. As I said, they're in the preprint itself, there's a lot more detail, some links out, a lot more examples. But hopefully that gave you a flavor for what the best practices are. And the kind of design of the best practices really is that they're general, and they should be applicable or usable or understandable by any scientific software registry or repository. So what's next? What's the next steps? Well, we're currently starting up a new CyCodes consortium. So it's basically a group of individuals that manage scientific registries and repositories. So unlike some of the RDA or the Force 11 working groups that are kind of time bound, we saw that there was really a need to have kind of an ongoing community, and there was interest to have a community of folks that run these types of resources for scientific codes. So CyCodes is kind of an umbrella continuing organization type thing that will hopefully be continuing on. There's lots of interest in kind of interoperability between resources and figuring out how we can do crosswalks, how we can kind of do more common indexing so that scientific codes are more available in discoveries. So if you run a scientific software registry or repository, You can join us at scicodes.net, and we also have kind of group community calls on the third Thursday of every month. And as always, feel free to email me, or you can find me on Twitter, and I'd also be happy to answer questions either now or at the end of this great session. Thanks, everyone.
Thank you. So that was software, but I kind of saw contours of what you need for any repository. Or beyond software.
Yeah, so the group was specifically software repositories, and a lot of our best practices were certainly informed by a lot of the work that's happened around data repositories and COAR Seal, but we wanted to both kind of fit the specific needs of software repositories. At the same time, it is very general, and so I think some of the best practices are definitely transferable to some of the data repositories as well. And certainly, as somebody who runs a repository that is for both software and data, I think all the best practices, we're trying to implement as many of the best practices as we can as well, and it maps reasonably nicely for both our software and our data entries.
That's great. Anyone else? Just unmute if you have a comment, or use the chat. Okay, thank you. So now we'll move on, and now we actually come to some kind of home territory here with the INCF and guidelines for data repositories and scientific gateways. That's a presentation by Wojtek Goscinski. So please, Wojtek.
Absolutely. Thank you, Jan. So thanks, everybody. My name's Wojtek Goscinski. I'm a professor at Monash University. My day job is as Associate Director in the Monash E-Research Centre, and my particular area is high-performance computing. But I have a general interest in applications of computational science to new areas, in particular computational imaging and neuroscience and structural biology are two areas that I particularly spend a lot of time in. So I'm presenting some work on behalf of the infrastructure subcommittee of the INCF, in which I'm involved. The work here presented today is particularly supported by Malin Sandstrom from the INCF. What I want to do is just give you a little bit of background into some of the work that the infrastructure subcommittee is doing, looking at best practices and recommendations in scientific gateways, portals, data sharing, and so forth. Our aim really here is twofold. Firstly, we want to help neuroscience researchers and students choose good services for their specific use case. And secondly, we want to help neuroinformatics service providers make good decisions when they're developing their service, when they're making it available online, when they're operating it, when they're decommissioning, and so forth. Now, I think these goals are very well aligned with some of the other work that we've presented, and of course, many of the best practices, the recommendations herein are very much in line with what's been presented. The purpose here is also to develop INCF knowledge to achieve the above goals, but also to build on the INCF standards and best practices process that's been developed some years ago and has been in operation for some time now. So just very quickly, the infrastructure subcommittee of the INCF very much acknowledges that fair neuroscience is dependent on computing infrastructure, including software portals, data repositories, clouds, high-performance computing facilities. So the goal of the committee is to bring together and build an active community of practice, researchers and infrastructure providers who share an interest in underpinning fair neuroscience through computational infrastructure. And there are the members there on the right for you, with support from Malin and from Matthew at the INCF as well. So the target membership of the committee itself is very, very broad and really spans large neuroinformatics initiatives with an infrastructure program, software developers working on neuroinformatics initiatives. So you can already see there's a broad range of interested parties there, from very large projects to individual software developers. Research projects that provide a service to others, high performance and computing systems and research clouds that have a particular interest in supporting neuroscience, such as our own. Practitioners with a particular interest in computing infrastructure, and global neuroscience initiatives with a mandate to provide accessible capability to their users. And all of these examples have some form of representation on the committee. There's a lot of heterogeneity in the space that we're talking about here. So just simply on the slide, we saw that there's a huge variety of different interested parties in this space. But in general, the topics that we discussed: software as infrastructure, data collections, collections of collections, portals, gateways, data repositories, and so forth, on which neuroscientists depend. This is a very, very broad area with a broad, wide range of knowledge required to provide capability here. We take the approach that there are, in general, across this space, quite a lot of really good, strong, common principles. So everybody that participates in the INCF infrastructure program is very much committed to open science and open source, underpinning reproducible science, very much on underpinning the actual science, not so much the infrastructure, but acknowledge that the infrastructure is a means to get better science. Sustainability is a particular challenge that's also been identified, and that's something that we very much talk about in the committee. So I want to talk a little bit about some of the work that we have been doing recently, and this is all very early stage work. In fact, this is actually the first time that it's presented outside the infrastructure committee itself. But the goal of this work and these last few meetings that we've had in late 2020 and early 21 is to articulate a clear set of best practices for neuroinformatics repositories and scientific gateways or other services. And again, as I mentioned before, the purpose is to help users choose and to help capability providers make good decisions. So I just want to, before I present what we have developed, start with, I guess, some user perspective and some service perspective as well. So we are targeting those two perspectives as individual entities, and both, warrant some attention within this process. So the user perspectives, online services are becoming standard part of the scientific process, but users meet specific challenges. So when they're using data repositories, it's a wide variety of questions. Which repository should I choose to publish my results? Which data license should I choose? Will this site be up in a week or a year or 10 years? And what will happen to my data if it disappears? Is this repository known and accepted by my community? These are all examples of questions that have come up. Specifically to scientific gateways, if I use this service, will I be able to redo my processing? Is this site sustainable? So if I invest the time and energy into using this scientific gateway for my scientific process, and as part of my scientific sort of workflow, do I know that it's actually going to be around tomorrow? So other issues with respect to communication, whether some of that is exposed, whether scientific gateways are actually communicating effectively with regards to changes in the back end, perhaps. And key issues about who owns derived data is an example. So actual issues of IP ownership. On the other side, from the service provider's perspective, there are significant challenges with operating this sort of infrastructure. So from the data repository side, what are our obligations to our users? How do we ensure data quality? How do we make this service sustainable? Sustainability is a thing that we've heard a number of times. What ethics should we require? Should any ethics be applicable at all to the data that we accept? With respect to scientific gateways, How do we build trust with our user community is a key question that's come up a number of times. How do we make changes to our service in a way that doesn't negatively affect users? What is best practice in IT for operating this service for our users? And particularly that one is one that I find that we, in my day-to-day job, face quite substantially. So what do we actually need to do to have effective IT operations for some of these tools and services where we're trying to be very, very dynamic and very fast moving, and there's an immediate trade-off there between the two. So of course there are very closely aligned initiatives here, and we've looked at a wide range of the literature in this space, but the two that have already been presented today are obviously fair sharing and Force 11 best practices for research software registries and repositories. So they're two that I particularly want to call out because they're ones that we've been looking at as good examples of best practices that have been published in this sort of space. So I'll briefly go over the actual criteria that we've developed for this consultation. And again, I do want to highlight that this is early stage work, and what we particularly have tried to do in our early days of this work is capture everything and then refine down and organize. And there is still a bit more process to go through with regards to refining down, organizing, and articulating these criteria or best practices in a very articulated and crisp manner. That will be a bit more of an iterative process, and perhaps reorganizing somewhat. But we do think that we've captured a wide variety of the requirements and the best practices. So the first is capability and description. And so that is just to provide a clear and concise capability description that outlines features, targeted community, usage and statistics, ownership, and citation. And the reason why it's important is to ensure that users are aware of the capabilities of the service, who operates it, and who is it for. And the format of these slides is just that we try to put together a very crisp, clear, readable description on the left. And we're also developing, I guess, a checklist, you would say, and that is presented on the right. The second is community and value contribution. So to provide a clear expression of the research community for which the capability exists as service and the value contribution that's being provided. And so fundamentally, who is it providing this service to, and what is it providing to that researcher community? And I think this is twofold, so that researchers are aware of this service, the scientific contribution that's made, and also that scientific contribution is appropriately acknowledged, which we've also heard here today, the importance of having some of these outputs be acknowledged as a primary research output. And finally, I think this is really important from a scientific trust point of view. In general, there is a bit of a trust building exercise here that we need to acknowledge that needs to occur between a user community and a scientific gateway or a research data repository. The third is with respect to licensing and data use agreements. This is very focused on the data aspects rather than the terms of use. I'll address that. So any and all licensing conditions of uploaded data to the platform or reusing data within the platform need to be clearly and transparently articulated. I think clearly and transparently are the key words there. Obviously, articulating these in some sort of a standard licensing model, such as perhaps CC or another well-articulated, easy-to-use English language or other language license is very important. So any process that contributes data to the platform should clearly outline the license being applied or provide appropriate options. And licensing applied to derived data should be made clear, and that's particularly important and sometimes isn't addressed. Responsibilities. This is with respect to the responsibilities of the service and responsibilities of the user. And you see this articulated very commonly now, obviously, as part of an end user license agreement. And although we all dread end user license agreements, they can be quite effective documents to clearly define roles and responsibilities between the service provider and the end user. And I think that there is some discussion to be had across the sort of scientific gateways community about what are appropriate end user license documents, end user license agreements. It's very important that end users understand their rights and responsibilities with using a piece of infrastructure. Next, governance and decision-making. So capabilities must be clear and transparent about the way the capability is governed, and capabilities should articulate the way decisions are made. Decision-making should be transparently communicated to the community and should provide user communities with a mechanism for influence. I think also it is somewhat tied up with funding. Fundamentally, decision-making and the way that systems and software is developed and systems are run is very closely tied with funding, because you may have funding to do one thing but not another, and that is very critical, very important. I think the key here is to ensure that transparency is provided to the users, so that users can see and understand funding sources. User engagement is key to all of this. Fundamentally, engaged services, engaged users have a better chance of sustainability, and also users understand that fundamental potential conflict of interest with regards to funding. Research infrastructure best practices and user support. And this is one that as I mentioned, we grapple with quite substantially, particularly considering we run a number of infrastructure projects with hundreds and thousands of users. So this is very broad. Capability should be operated with best practices, IT practices, including user communications, backups, documentation, security controls and updates, privacy controls. That is a very, very broad statement, and in itself requires a significant amount of work to unpick beyond the scope of this presentation, obviously. But this is certainly something that we want to drill into a little bit more to understand what are the infrastructure and IT service best practices that other gateways and data infrastructures are actually providing to run their operate their service, and to perhaps provide some advice to both users for what they should be seeking from infrastructure providers, and also to infrastructure providers on what they actually should be doing and what is considered best practice. And finally, sustainability and persistence. So the capability should develop a sustainability plan and publish it for users to review. Sustainability plans should address shutdown and archiving matters such as archiving or data preservation. Sustainability is something that's very challenging in this area, and we have seen a number of major services that have gone on offline or are seeking funding to continue. Some of this work is specifically to address that as well. So we do very much hope that a document such as this will provide mechanisms for infrastructure providers to understand what others are doing with regards to sustainability plans and so forth. We are starting to see discussion around sustainability plans come from, for example, the software gateway community in general, and I think that's a very positive thing. So these are the recommendations at a very high level, and I won't read them out again, but this is where we're at in that journey. The next steps that we're going to go through as committee is to, I think, perhaps refine the structure of these a little bit more and to articulate the language. What we plan to do after that is to publish this publicly for open source comment. And so I do invite you, once that's made available, to please comment on that and provide us with feedback. Thank you.
Thank you very much. Okay, so here we have the neuroscience perspective, or part of the story, so to speak. So what do you think, Wojtek? Is it really different, this neuroscience piece, versus the rest of what we have around us?
No, I don't, Jan. But I think it's important for every community to go through this journey in some way, shape, or form. And I think that's, you know, that's what the INCF is helping here to do. And I think that has value. I'm very mindful that when you look at various different communities, they're all at a different stage in this journey. They all have slightly different versions of the same problems, and that's okay. But they are all on a different, a different time frame here with respect to these sort of journeys. And you kind of have to respect that. And neuroscience is somewhere along the journey. And we can look to others for some thought leadership on this, but also there are a number of areas where neuroscience, I think, is doing quite well with respect to some of these, particularly in the neuroimaging space.
Good, thanks very much. Okay, I think we can move on. And well, I think I learned what COAR means. That's about time. So that is consideration of open access repositories. That's something we really want to hear more about. And now the talk is by Kathleen Shearer, please.
Thank you very much. I'm just trying to get down to the, okay, so let me go up here to do the slideshow. How's that? Is it in full screen now?
That's fine, thank you.
Excellent, great. Yes, thank you very much, Jan, and thanks for inviting me here. I'm delighted to be here. My name is Kathleen Shearer, and I'm the Executive Director of the Confederation of Open Access Repositories, or COAR for short. So COAR is an international association. We were launched in 2009. We evolved out of actually a European project to connect repositories in Europe. And of course, because research is global, the Europeans realized we actually need to have international alignment and interoperability across repositories around the world. And thus COAR was born. We come from the perspective originally of connecting more literature repositories, so supporting the open access movement, and in a way kind of generalist repositories. But as we have grown and evolved over the years, we have a number of members who are interested, many members who are interested in data and other types of repositories. So at the moment, we have 157 member organizations from 52 countries around the world, representing libraries, universities, research institutions, and government funders. And we engage directly with our members, but we also have a very strong national and regional repository networks that we also engage with, including La Referencia in Latin America, Open Air in Europe, which are the two most well-developed repository networks, but also in Japan, China, Africa, and other places. I'm just going to try to move these windows up if I can, but no, I can't. Okay, so COAR has really, our main aim is to strengthen repository networks through promoting good practices, capacity building, international alignment and interoperability, and innovations in the platforms. We really think about how we're going to break down silos across countries and regions, but also domains and repository types. And as several people have mentioned already in their talk, you know, there are a lot of different requirements or frameworks that have come from different communities around what should be best practices for repositories. And our community was confused how all of these practices fit together, which ones were more important than others if there was a conflict between them. And so we decided to embark on an exercise of looking at the various existing best practice frameworks to see how relevant and appropriate they were for the community that we represent. So we decided to, as I said, do this, and we began this work, I guess, in early 2020, and the aim really was to develop a global multi-dimensional framework for assessing good practices. So something that would work for all types of repositories, not just data repositories or software repositories, but a baseline for all types of repositories. And we brought together an international working group from the repository community. We brought together all of the existing frameworks and recommendations. I'm sure we missed a lot of the domain ones, but we brought together as many as we could. And then we asked this group to really look at these requirements through a lens of how easy are they to adopt in your own local context, in your repository? Do you see any gaps in these existing frameworks? Are they clear? Do you understand what they're recommending? And how relevant are they for you? And so based on that work, we had an initial draft that we brought together the recommendations that we thought were most appropriate. We added some more that we felt were missing in terms of the other frameworks. And we shared the results of that with the community in August 2020 for feedback. And we received feedback and we incorporated that and published our second draft in October 2020. And it's been really embraced in our community, at least, because our members have translated it into 8 languages. So there was a lot of support for what we did. And so just to give you an understanding of what we have, how the framework is structured, we have essential characteristics and desired characteristics for repositories, and each characteristic is connected to a specific objective. And I think that's very important because it's important for the community to understand what we're trying to achieve when we apply these features or criteria. So I'm not going to go through each one of these, but I'll take you through each section and point out a couple of areas that you know, might be of interest to you. Of course, this is available on our website, and I welcome you to go through and browse through it. But metadata, somebody earlier had mentioned metadata and the importance of metadata. So one of the essential characteristics is quality metadata. And of course, that's a very vague thing to say, but in a way, it's hard to be prescriptive at a baseline level about quality metadata because there are different metadata requirements in different communities. Persistent identifiers is another essential characteristic. Making sure that your repository is indexed by discovery services and is part of registries and directories. The second objective is, so that first objective is about discoverability. The second objective is about accessibility. So you know, one of the essential characteristics we have here is that there's no cost for the user to access the data. And device neutrality. So especially in developing countries, there's a lot of use of iPads and cell phones, much more than we might see in the Western world. So it's important that data is available, that the repository supports those other devices. The third objective is reuse. So this is about PIDs, about some of the FAIR criteria, about licenses and making sure licenses are clearly stated, as one of our previous speakers said. So the fourth objective is integrity and authenticity, and this is really about making sure that it's secure, the repository is secure, nobody can go in and manipulate the data that's been deposited, support for versioning, and then quality assurance. So does the repository check the data? Does it undertake some basic curation for the metadata and so on? And then there's some requirements around privacy of sensitive data. So does the repository, if the repository is collecting sensitive data, does it have mechanism to limit access to authorized users only? Some requirements around preservation, and this is really the trust aspect, preservation, sustainability, and governance. And then some other characteristics such as, is there a help desk? What is the scope of the content you're collecting? Make sure that's clearly articulated on the website, and those kind of things. So that's the overall framework, and the intent really is to do a review with the community every year around July or August, bring in anything new that's come from other communities that are relevant. And so we really want to make sure that this framework is continually kept up to date, and provides access to, again, relevant criteria that are coming from other communities. We also hope to begin to provide more detailed guidance and support for repositories, because our community was asking for that. So a lot of the criteria in the framework are quite vague, and the repository community could use more detailed instructions about how to implement the recommendations. And then, of course, I think it's important also to for the community to understand that this is really, again, like a baseline, and there are more comprehensive recommendations or requirements by other communities depending on, specific domain requirements or different content types, like we heard about software earlier, or data, or different funder policies. So what we'd like to do is enhance our framework by linking out to other existing framework that have more detailed recommendations. And so maybe just some concluding comments based on some discussions we've been having, about the importance of good practices frameworks, but also the danger that they could end up disqualifying some repositories. So it's very important to get a balance of adopting good practices and encouraging the repository community to implement them, but making sure that they're not applied in a way that disqualifies a lot of repositories. Because what we really need is to have this very diverse, distributed ecosystem to support open science. And that means we need a lot more repositories than we currently have. So I think this issue is particularly important for the developing world and domains perhaps that have less resources. So in the developing world, it's important to note that there's not funding for domain repositories. There's not a lot of funding for domain repositories in those environments. And the way open science is evolving in developing countries is around institutional repositories. And that's a very good way to build the repository ecosystem in developing countries, because universities are long-lived and sustainable organizations. And so part of what COAR is doing is trying to encourage the development of these types of ecosystems, especially in developing countries, because it's a much more sustainable approach for them. So we want to recognize that as we do move towards better practices, more functional repositories, we also are sensitive to the diversity of jurisdictions and domains. And I guess just to finish, I think it's also, I know FAIR has been very important in advancing our thinking around how we want to, the operational aspects of our repositories, but FAIR are not the only things we want to aim for. It's very, in some places it's very, or some communities, it's very important jurisdictional preference. So we have to think about, in Africa, do we want to send, if they don't have any FAIR repository, should they be sending their data outside of Africa? There's a lot of sensitivities around that in Africa and Latin America in particular. Or the governance model. Some communities may really want to have community governance. That may be more important than a repository that is completely fairized, shall we say. So we need to keep all of these things in mind as we move forward as a global community. And with that, I would say thank you very much, and I welcome any questions you have.
Thank you very much. Now, that was very clarifying on a number of topics, absolutely. So let's see now, we have an opportunity to go in depth here at a number of points. And we have also some questions in the chat, but maybe just to ask you, Kathleen, regarding some of the things you brought up at the end of your talk there. I think you touched upon the willingness to share. That is often a challenge as well, that there's this general expectation that sharing is a new standard, but sometimes there is also a little bit of reluctance to do it. Did I understand you correctly in some of those remarks?
I don't know if I mentioned that, but certainly I think that's true.
Yeah.
There is, I still think, we've only scratched the surface, shall we say, with the research community around their interest in sharing, and especially with data, because data, of course, is their, how they build their careers, and there's a reluctance and a concern about being scooped and so on. And I guess there are some domain communities that are farther ahead with that than others, but certainly I think there's a lot of work to be done around incentivizing the various communities to share their data.
Great, thank you. So I think it's fair to say that we now have a fantastic overview of a number of different topics, all relevant for the session. But it's also fairly complicated. I mean, would the speakers agree that this is kind of a big field? And imagine you come from the outside and listen to the session. It could be overwhelming. Yes, please turn on the cameras. That's great. Thank you. Would any one of you want to comment on that perspective before we go into more specifically things from any point of view? Anyone want to start commenting on that? The fact that it could be a bit overwhelming to someone who wants to kind of try to understand what we're discussing? Or
so I guess I would just say that I think it is confusing, but it's no more confusing than the scholarly world in general. And it's just that there's a lot of different aspects. And I think if you focus on any one of those aspects, it's not confusing. But if you think about, I mean, what a professor does in general, what a researcher does, there's a lot of different things. And so there's a lot of different elements that go with that, because each of those things that a researcher does that interacts with the scholarly ecosystem, there's the opportunity to do things better.
Sounds like Dan has had that question before. That's good. Thank you. So can we summarize in some way what the most important things would be now for, let's take a perspective of someone who, this is taken from the chat then, someone who wants to or has some resources and starting maybe fairly early stage in building repository. Could you summarize the main things that that person or that group of people would have to think about, where they should go to make the right moves? Do they have everything through the talks we had?
Yeah, I mean, I think there's one component is to try to use existing solutions, either in terms of repository software or repository best practices that are existing. So there's a lot of existing software platforms and services that can be utilized. And so not having groups try to reinvent the wheel, I think is very important. And I think the other thing that we tried to capture in our best practices is a lot of it is around transparency. And it's around making information about how you're running the service of the repository, the registry, available on the website. And it's not like we necessarily need to have very fancy things. It's literally it could be an FAQ page. It could be just writing up details about how your service is running, how you're making decisions, and making that really clear to the world that this is how we're running the service. And there's a lot about kind of transparency and making things clear that's important for somebody that would be starting out with this type of service.
Good. Any other
I just think that's very good advice with regards to transparency. If you had to distill it down into one word, I think that's a very good one.
I can perhaps add something more specific to the question that Marianne has asked in the chat. If somebody starts now, and obviously we are going to drown with all these different initiative working group that they're doing. And I think like Dan was saying, this is normal. This is how things start in different places. So if somebody's starting new in this moment, I think I will definitely always recommend to have a look at all the initiative and somehow do some sort of a kind of a mapping to really understand what they are after. Because in reality, if you really brings together all this initiative, especially the initiative on feature data repository, we are all saying the same thing. There is nothing new or unique in my view. It's the wording, or perhaps it's the granularity in which certain descriptors, certain features, certain characteristics are spelled out. But in reality, we're all, they are all good practices in general. So yes, there will be some initial work to do until there would be some convergence, if there would ever be, or somehow map this initiative and then everybody choose using this mapping as a starting point. But otherwise, like Daniel was saying, perhaps the people that at the moment are really the target of this initiative aren't the researcher, but are people working in this area, and those people will be skilled enough to navigate, because there are way more complex things to navigate than this one, I would say.
Good. If we think about INCF, you heard Wojtek's presentation. So the neurocentric view. Any one of you who come from outside or different areas, any particular advice to INCF or those who in general work with the neuroscience repositories, and most of them are really early stage?
I would certainly say to Wojtek, consider joining this new group that will probably start in RDA to try to map this initiative together. It's a way, again, to map what you are doing with your own language, with your own label to others. That's certainly one thing you should consider.
Yeah, I really liked your starting point, where you're at now, Wojtek. I think you've done a really good job in terms of identifying the major issues. And then the challenge really is getting those repositories up to, the place where they're able to support what you need. And I think that's the really hard thing, because that often takes extra resources on their part. So, for example, if a repository, as Tom says, adopts a solution that's already out there, an open source, is using an open source platform, well, that platform may not right now support your requirements. So you kind of need a roadmap to go from where are the repositories now in terms of their functionality to can we move them towards supporting the requirements that we have. And so I think working closely with them is from the start, and recognizing that they may have some resource challenging around supporting your requirements is an important starting point.
And I guess I would say that from my point of view on the software citation side, it's not really necessary to do anything too different with repositories. You can use repositories that already exist if the INCF related repositories are able to support software in the way that Tom was saying, then that's even better, but it's not a requirement. The thing that's the main requirement is getting the actual researchers to understand why we're asking them to do more things, and what the value is to the overall community and to some extent to them as well of doing those things.
Yeah, I think in particular, one of the challenges is that neuroscience is obviously not just one community. It's many communities, and there's within neuroscience, there's varying levels of maturity, and that's entirely normal and that's entirely natural. And there are sub-communities with sub-communities, and there are repositories that support various aspects of that. So you have a lot to unpick there when you really examine it.
Good. So if we were to try to follow up a little bit on this one, whatever we do and whatever you have told us about today, is there a way to always look for kind of the minimum of metadata, the minimum of desired characteristics, the absolute requirement? I mean, the world is complicated. There's many aspects to take into consideration, but what do you as a group think about kind of moving towards certain minimal set of information for those who are either using or building or having a role in this world of repositories? I saw a little bit of it, but I was expecting a bit more. Is it the right way to think in those terms, or do we need to keep it open for dealing with everything at the same time?
I certainly think from the outcome of the session that we had, that there was an interest in coming together to identify a course set. And the course set will never be enough for everybody and everything, but potentially will be a common point.
Yeah, I mean, I agree. I think starting with the minimum is the best way to get started, and then over time you can build on that and bring in others characteristics. But if you start at a very high level, then you're at risk of losing a lot of your repositories that can't support some of the requirements.
And if we do that, and if we try to start with a minimum, what's your experiences with having some kind of minimal requirements or whatever they are as a standard? Because it doesn't help if the minimum is different all over the place. Who can be bold enough to push something? I mean, INCF for neuroscience can help in this regard, but it is a challenge, I guess, because we also want things to be interoperable as much as possible across all disciplines. Many of these things are not just one field. Anyone here who can take responsibility for that part?
I think that every community has their own authority, and here everybody is just like, do their own part, and then you bring your own community along with you. I don't think that all the community respond to the same, let's call them authority in the sense, so, they have the same reference point. So that's why, for example, the Elixir group follow what Elixir does, NIH, you're funded for NIH, you follow what NIH does. But obviously, if we build convergence among those initiatives, then we help those community, to be consistent and coherent as much as possible.
Yeah, and I like the idea of kind of having a more broader set of criteria, because what we saw just among kind of software registries in particular was that everybody has a different perspective, a different set of implemented tools and capabilities, and so trying to pin down even a minimal set of metadata. We kind of went around the room and ran through everybody's internal metadata schema, and there were like 3 fields that were in common between all the resources. So trying to get, too strict on our standards in saying, everyone must store their author lists in this way. It starts to kind of break down the community boundaries, because then people start to get very fixed on their implementation. Is that I've implemented this way, this is the way they want it. So I think as a kind of a general standard, if we can keep things really focused on what we need to be able to do interoperability, which is kind of transparency and making data available. If we can focus on what our goals are around sustainability in terms of making sure that we understand when services are going to be available and not. And so I think a lot of it is kind of around information sharing. And if the information is available, then we can do the downstream work to start to figure out how to actually interoperate different resources. But trying to have standards where we force everyone to do everything exactly the same way, I don't think is going to be a productive approach.
So another thing that would be possible would be to create some challenges, right? Something that the community really wants to do, and then have different repositories kind of come together in a meeting and talk about what they would need to do in order to support those challenges, and then to try to use that as a minimum.
Good. I think we can see the balance here between different needs under the real world situation very well with your comments. So is there a particular role for journals in with regard to these topics we're discussing here? We heard a bit about journals, perhaps particularly from you, Susanna, and we also saw journals recommending repositories. My impression when looking at that today is that, yes, you can find these lists of repositories recommended by journals, but it's looking different when you go between different publishers, and it's not entirely clear to me how it's working, and that's very understandable. But do you see any trends here on how this is evolving, or can something be done to optimize it a bit?
Yeah, that's one of the presentation. Actually, the first one in the session was from the publisher, who got together to try to understand about themselves how they were choosing this repository, based on what feature. And they've put together a draft, which I know has been commented, from several community, and has been seen a little bit like a threat from the publisher trying to impose certain repository of another. I generally think that's not the intent, and they expressed that very clearly in the session, in my view. They are part of the scholarly system. Authors go to them to ask those questions. So I think the closer we work with them, the better it is, rather than the other way around, that we alienate them because they are engaged with the researcher. Maybe they own set of researchers, but nevertheless they are. So it's a complex system, Jan. It's just another stakeholders that has to work together with everybody else.
Is probably a good description, yes.
Or so on the software citation side, as I mentioned, we had a journals task force, and we've had about 20 publishers involved. And it seems like the role of the publishers there is not to say that everybody's going to do everything the same, but to talk about what they need in order to do things that are consistent. So what information needs to be in a software citation, right? What are the repository, what's the requirement on a repository to be minimally acceptable? What kind of identifiers can be accepted? Not to have the same standards, not to have the same formats, not to have the same styles, but to have a minimum set of information that's needed. And then to think about within the overall publishing system, how does that information get to indexers like Crossref, and so that citations can be counted. So it seems like there's a bunch of things there that are very very specific to a journal, but there needs to be agreement, and I think we're getting to that point where there is agreement now in many cases on what the underlying information is, not what the presentation is.
Good. I think we probably have touched upon topics that and questions that you actually can comment on and have given very helpful comments to. So should we try something that perhaps you cannot comment on? And if you can, I think you're good. That is the sustainability question. Because it's so hopeless that you may wonder who's going to say anything sensible about that. If there is anyone who has a comment on sustainability that's meaningful, I would be pleasantly surprised. Can you surprise us?
Well, I have some thoughts on that. I mean, I think the reality is we need to fund repositories as essential research infrastructure. So I think we need to rethink how we're viewing these kind of services, which often grew out of, for example, projects. You know, data repositories, as an example, may come out of a specific project, and then, of course, when the project's over, there's no funding for it. Or there, you know, are domain repositories, but they're on 5-year funding cycles. So I think we really need to rethink how our infrastructure for open science is being funded, and that repositories are essential infrastructure components of that. And I do see that happening now in some places. For example, in Canada, where I'm based, you know, we have just a new national organization that's been launched around research data management. So we're seeing rollout of a lot of infrastructure and centrally funded infrastructure for Canadian researchers to support data repositories and other types of repositories. And then the other comment I have around that is related to the institutions and the role of institutions. And I think it's an extremely important role. Institutions have funded scholarly communications, a history of funding large amounts of money to the publishers for journal subscriptions. And so I think there's an opportunity for them to repurpose some of that funding towards institutional repositories, which are extremely important parts of the ecosystem, because we'll never have domain repositories for everything. And so I think that's another sustainable way, is the institutions picking up a big part of this and launching and hosting their own repositories.
Yeah, I wanted to second that comment, Kathleen. That's something that we're working a lot with at Caltech, and thinking of our institutional data and software repository, not just as a place where we can store stuff, but as really institutional infrastructure to support kind of disciplinary specific work that's happening at our institution. So for example, we've got one climate network data set that we're hosting. And so the way it works is that the specific domain site, the landing page, the interactions with the data, the group runs that, and they're responsible for maintaining that. But the underlying files, we store those in the repository, and then there's an API where we can then get access to the files. So one of the models that we're kind of exploring is being able to split out some of these kind of disciplinary specific functions and have the institution be responsible for the low-level storage, the management of the DOIs, and the persistence of the files, really. And then have the kind of domain-specific work be the more kind of scientific gateways, the more exploration and visualization, all the kind of custom work. And by splitting those, even if we, can't, even if we're kind of experimenting with different ways of looking at the data, if that stuff, isn't sustainable for the long term, well, if we can still maintain the data, if we can still maintain some of the source code that was used to generate that stuff, we can better support a lot of the work than kind of the current funding model of spinning up an entirely new service from scratch and then trying to have to find funding and sustainability for all these independent small services. So we're really excited by having kind of more institutional support for at least some of the lower level infrastructure type of stuff. to allow the researchers to do what they want, but to also have it be sustainable.
So a possible interpretation is that some specialized repositories may not live forever, but they can do a good job in promoting a particular field of science, in maybe organizing, managing data, bringing together particular collections that come from many different sources. That has a value in itself. But if you think in the longer term, the fact that institutional repositories are the ones that most likely are the most sustainable, can kind of rescue not all the aspects of the individual smaller ones, but at least make sure that the data are there. This reminds me of a discussion we had with some users of our service where the person was saying, well, I realized that my funders require me to do something with my data and share them through this or that mechanism. My institution has a rule that I have to make the data available here in their repository. And then the European Commission has these nice solutions, which I now can realize are very useful, so I should use them. And that's quite a duplication and triplication of the storage and whatever you have. But my answer at that time was go to the place that produces the value with the metadata and making it discoverable in the right community. And when you have it there, then copy it to the other places. Then we actually took care of the sustainability as well, in case that was a problem. So maybe there are ways to think positively about this difficult question. Well, we have a long range of topics that we could touch upon.
Can I jump in and add something still on this?
Absolutely.
For a second. So I think I wanted to say two things. One is regarding Kathleen's point. The Open Library of the Humanities, I think, is a really interesting model to look at in terms of how such institutional repositories and institutional sources of publishing can be supported. And so I think that if anybody's interested in that and kind of curious about the business case, then that's an interesting thing to look at. In terms of the sustainability question more generally, so the reason that we're really pushing software sustainability is because software, unlike data, will stop working at some point unless people are continually actively maintaining it. And so we need to incentivize people to do this kind of work. We can't just put software in a repository and say then somebody in 5 years can take it because it won't work. The platforms will be different. There will be bugs that have been found, things like that. So the real question for us is how do we incentivize people to work on keeping the software going? And one of the methods that we've chosen here really is citation, that they get credit for when their software is used. And so if people get credit, then this shows up both in terms of their reputation, but it also can show up in terms of the institutional reputation, right? This software has been developed by people at this university, and this university becomes known as a center of expertise for this kind of work and these tools that are the things that the community relies on. So I think the part of the answer, at least for us, for sustainability, is to use the system that we have and to try to figure out how do we incentivize people to work within that system. So how do we treat citation as an element of hiring and promotion and tenure? How do we treat citation as something that disciplines create rewards and awards based on? And so I think, again, thinking about the researcher, coming up with new things that they have to do for new reasons probably isn't going to work. But if you can say that there are things that they're going to do that'll make their job better and will make them better recognized, then I think that's much more likely to be successful.
It's all about creating an efficient business model. And of course, any CV from a younger researcher nowadays will for sure not only contain list of publications, but it will contain list of data sets that are shared or software and so on. And if we could have the citations in addition, that would help a lot. Sandra, would you like to go into the session, turn on the camera and take a question there? I think you have in the chat.
Happy to. I was just enjoying the discussion. I think part of the thought process that comes around repositories, whether at institutions, centralized, at whatever level, is in the context of neuroscience, where we're talking about not just a few megabytes of PDFs or a few gigabytes of PDFs. We're looking at petabytes of data coming into existence over the next even 1 to 5 years time span. And these coming from individual research projects, not even the whole scale of neuroscience around the planet. And this brings together this juxtaposition of compute and data kind of close to each other in some sense. When we think of repositories at present, a lot of these are focused on kind of archiving or storing data without thinking about computation. So one of the questions to the group over here is, what are some thought processes, both at the institutional level, but also at the pragmatic kind of scientific level of bringing these two components together? And how should institutions approach that? Because many institutions don't want to run services. So how should they kind of think about that space?
Can I jump in here? So this is something that we do tend to think about, and because I'm Australian based, sometimes accessing data from the other side of the world can still be a pain. So we do tend to get a significant amount of requests to move data locally to Australia, particularly when it comes to large, for example, neuroimaging collections. So mirrors of the Human Connectome project or the UK Biobank data sets are entirely useless without the compute. They're just of no use whatsoever. So we are taking a very different approach to this now, and so we're actively working on projects that really provide both in the one location, and that's really a major focus of some of the new, I guess, scientific gateway work that we're leading in Australia, where it's basically a one-stop shop. You get access to the data set and you get access to the computing infrastructure also to process that data set. It's not particularly more sophisticated than that. It's just a very simple solution, and that is to put this on a high-performance computing infrastructure or to put it on a research cloud.
Are you doing some of the same yourself, Sasha, in this regard?
A little bit, but it's still hard at the institutional level. And I think that's the picture I want to kind of bring up is who gets access? Is it local? So if you think about the scale of data, let's say I generate a 2 petabyte EM image. It's not going to move too rapidly. So what are the policies that should happen at international brain initiatives or institutional levels to say, I can provide other people who want to compute on this access over here. And I just wanted to kind of bring that up, as that does not become a trivial thing in many cases. And especially if we kind of think about democratization of data on one hand, which many of the repositories are providing, how do we think about democratization of compute when the two are kind of connected together?
It's a really good question. So how does somebody get access is a really good question, and we've worked on many different models, and we applied many different models, from just democratic access, which gets very busy very quickly and the service gets oversubscribed and becomes useless, to merit access, which imposes a number of major barriers that sometimes are effective and sometimes are not, and sometimes are appropriate and sometimes are not. So I don't have an answer for you there, actually. I think it's a really good question. But what I will say is that sometimes an interesting motivating factor is the researcher who produced the data. So we do find this increasingly, as I think your own example seems to be mirroring this. So a researcher comes to us and say, I have this 3 petabyte file system, 3 petabyte data set. I need to provide both the compute for my collaborators and the data. And without it, I don't get credit for the data that I created. So whose responsibility is it to pay for that then? How do we provide that complete environment to collaborate over this data? It's an interesting problem. But I do think, I mean, I work for an institution. I do think institutions have a role here if they want their researchers to succeed in this space, the space being big data type science.
Topic is very relevant for this session, but it's also kind of maybe a little bit outside of what we focused on today, but I'm sure there are many initiatives around the world that kind of struggles with these challenges. I could mention what we are doing at the European level in the eBrands research infrastructure is to have user accounts. That's fairly easy to have. With that follows certain resources also on the computing side, but not very large resources. But it's kind of a first step, which comes for free. But then if you need more, you need to apply. And you need to have a project that goes through a review process. And at this stage, we offer free access to some quite substantial resources, but there are always these limitations. And so it's interesting to see what happens in different projects around the world. US Brain Initiative must be thinking about it as well, with the many resources you're building there. So this is maybe a topic for some other kind of session as well. Any other comments on that?
Just a quick one. Certainly this computing is not something that is tackled at institutional level, certainly not in Oxford, but I work with Elixir, and Elixir has a big Galaxy community. So practically, you know, I guess you're all familiar with Galaxy as a web-based platform for the computational, you know, biomedical research. And the idea it's really more to facilitate the uploading of the data, which is in the public databases, especially the core data resources, to the Galaxy, to make sure that the user can especially user with limited technical skill can make best use of the data. But within Elixir, there is even a computational platform and a dedicated Galaxy community, which is, you know, almost separated from the core data resources, because it's indeed its usage, and it requires a whole set of different skill, technical infrastructure, and like Jan will say, completely different sessions to discuss about that.
Good. Let's see now. We have several questions. I wonder if Daniel could take a look in the chat and check if we covered the one there on software citation, or we
didn't really.
No.
So sorry. So I don't know who can see this. So I'm just going to read it for a second. So
if you would do that, please, just do that. Thank you.
Software citation seems really very difficult to me, because software implicitly includes the entire platform it was built on. Specifying a version of software requires citing the OS, userland, kernel, hardware, cluster, processor instruction set, optimizations. In practice, a lot of software is not written to work on more than this year's most common platform. Seems like the storage requirements for software citation grow exponentially. Where are we in dealing with this? So, right. So I think there's a bunch of different things that are kind of being asked in this question. And so one of them, I think the easiest one, is that software citation, the principles for software citation say that you should cite the software that you've used, not that you should cite its dependencies. So hopefully there is a relatively limited amount of software that you're using. That software is using libraries for various things. It's using OSs, it's using other things. It's not your job to cite all the things that are there. It's your job to cite the things that you use directly. We need to get to a point like we have in papers, where you cite the paper that you looked at, and that paper cites other papers. And if you're interested, you can kind of go back in history and see what the chain of thought was. But you're not, if you write a paper, you don't cite all the work that was ever done in an area. You only cite the things that you were looking at directly. So I think that's one. The second thing as an answer is that, as I tried to say, the intent of citing software is for credit. It is not reproducibility. And so things like what optimization was used has nothing to do with credit. That's a reproducibility problem. So I think, again, if we think about just citing software for the purpose of credit, it becomes quite a lot simpler, because you cite the thing you used. And the biggest question usually is who should get the credit, right? Who are the authors of the software? And if it's open source, that can be hard to figure out. And so the recommendation we have there is to cite the name of the project if the project doesn't tell you who the authors are. And if the project gets to be unhappy with that over time, maybe they will tell you who the authors are in the future, and then you can do better. but it's probably the best thing that you can do when you don't know who the authors are, is to cite the software, the project as the authors.
Good, thank you. Right, so now we have several questions here. Marianne Mertone is coming in with some comments on being intrigued by a model where communities develop domain-specific repositories on top of shared infrastructures, fielding the costs for curation rather than building and maintaining the infrastructure. Yes, focusing on what is specific for the domain and not on the things that maybe others can provide just as easily. Anyone with experiences in this regard in our group?
Well, I would just say I think that's exactly the right model, and I think that's where generally the global community is moving towards.
Yep.
And their challenge around that is, funding. So, how does the shared infrastructure get funded? And so I think the easiest way for me forward with that is national infrastructure that will support these kind of infrastructures and services.
European level, we have EuroHPC, for example, which is kind of a platform.
Or regional, in Europe.
Yeah,
and like
that
Europe.
too. Yes, yeah.
I can say something on that too. I mean, for me, shared infrastructure work well or work best when it's more generic repository. In fact, Marianne mentioned, right, and Zenodo, when you start going very specialized data, having been somebody who was built in collaboration with other colleagues, many of these resources, sometimes it's not that simple to extend a model of a resource if you're trying on existing infrastructure, because this has to be flexible enough for you to make that extension, and you will still have to build the UI and everything else. So almost you end up doing, I don't want to say as much work as extending it as building from scratch. I'm not saying that, but really depends on your use case. And as Maria was saying, and then the rest of the effort is putting in curation. And I really would like to put a big emphasis on curation, because usually you tend to get funds to build something, but not to curate or populate it. Okay, it's even harder to get funds for curation, so it's almost the problem isn't the development part, it's the curation part. That's my view.
Yeah, I completely agree with you. And one of the things we're discussing now at COAR is how we can develop some shared curation models too, because, as you say, funding for curation is hard to find, yet we have these amazing staff across our institutions or across our communities. And could we take a little bit of that staff time from many different places and put them together towards a shared curation model? I don't know if it will work, but I think it's
a brilliant idea. Let me know if it works, or let me know if we can somehow contribute, because this is interesting. And maybe I also, as a flag, and given that we're talking about neuroscience, there is the International Society for Biocuration, which has been very active, obviously, in life sciences, because there's a lot of, history on curating and maintaining. And I think the struggle there, it's consistent and persistent. And if you have somebody, if I employ somebody that does curation for me, I will be very protective of my curator time. So I think it will be interesting to see how the model could work, because you need also the specific domain expertise, in curating the data, which is very precious, very undervalued. They are very badly paid, let's say it, and it's very little you can do if you are their own employee to try to keep them, retain them. It's really very hard.
It's a very important topic. Many of us are motivated for a discussion into that one. The domain-specific aspects is probably very hard to ignore. I don't think the curation will work without that. But some element of centralization and avoiding that you just spread it out and everyone is going to curate a little thing and there's no critical mass and nobody's really properly trained, that's not going to work. So you need this element of centralization. Some of us are quite interested in that, actually.
There's a network in the US actually called the Data Curation Network, which was funded, I've forgotten through which organization, but basically that's what they're doing, is bringing together people who have curation expertise in different domains to help cross-pollinate repositories that are in institutions. But I think it could work in the context of a disciplinary repository as well.
Good. We have another question also from Marianne Martone. The use of commercial clouds can push the cost of access to the data, to the consumer for very large data. It is hard to think of another way of doing that. How does that square with COAR's requirements that data should be free? Well, not only COAR's, but several probably would think that's the best. Kathleen, do you have a comment on it?
Yeah, I mean, it's something we talked about, that at a certain size, the data, it would be hard to not apply some kind of fee around the data. But I guess the discussion was centered more around the owner of the data rather than the user. So would the fee requirements be towards the data creator who's depositing the data in the repository rather than the user to access? And I guess that was the preference for us when we had the discussion, but it's a challenge for sure.
Good. So there's certainly very good projects on the way that try to do this using Amazon Cloud, for example, and other such resources. And there are also other projects that are more closely connected to high performance computing centers, which may have other cost models or other support mechanisms that in some cases can be helpful for many scientific disciplines. So let's see, where are we? I think we are probably, unless there is some reaction or some other thing coming in on the chat, probably going to a little bit of a summary. So first of all, I would like to thank all of the speakers for coming with all your extremely valuable and interesting input today. You made it a little bit complicated for us a while, but it was very clarifying, and we really appreciated all your valuable additional information in the discussions. And well, the INCF has a job to do, and as you heard, it's on the way, presented by Wojtek. And INCF has a number of other things going on as well, which can be helpful. For example, an alliance of journals, Neuroscience Peer Review Consortium, 40 journals or so, which I think can perhaps at some stage also come in as handy on the way forward, since we learned today quite a bit about how repositories should have a relation to journals. And my personal thinking is at least that journals can also influence scientists quite a lot in terms of not having all kinds of strange requirements, but some requirements that pushes things in a certain direction, which in turn can be helpful for some of what we discussed today. So I think that might be a way forward. So we covered a lot of grounds, not everything, but we'd like to thank you again, everyone, and for everyone listening in to the session. And then have a nice morning, evening, afternoon, whatever there is. Bye for now. Thank you.
Thank you, Jan. Thank you all.
Thanks, everybody. Bye.
Bye-bye.